Hello everyone, welcome to Power Quality Video Lecture. Myself Dr. Prasad. This In this video we are going to study about Introduction to Power Quality. Supplying quality power is one of the representations of nation's prosperity because electrical energy is the beating heart of any industry. Hence it is most important to maintain the quality status, the flow of electricity. Good power quality is essential for both high-tech and low-tech facilities with limited tolerance of electrical disturbances. Considering these facts, maintaining power quality now becoming a big challenge to the power engineers. Power quality problem may arise in any part of the power supply chain. So that means it may arise in transmission side, distribution side, or end user side. So hence it is required to develop the solutions at transmission side, distribution side, and end user side. That means the solutions is need to develop across the supply chain. So in India, so there are about 15 lakh industries are continuously operated. All these industries are used variable frequency drives, automatical speed drives. These drives will inject voltage disturbances in the grid, which leads to poor quality issues. So poor quality issues are voltage sags, swells, transients, interruptions, frequencies, noise, etc. So coming to the definition, so poor quality is defined as any poor problem manifested in voltage, current or frequency deviations that result in failure or misoperation of customer equipment, or according to IEEE standards, the poor quality is defined as the concept of powering and grounding of sensitive electronic equipment in a manner suitable for the equipment. We already know that the poor quality issues may arise in any part of the supply chain, so that the poor quality is also defined at different stages. So there are different poor quality definitions are there at different stages. So that means at the distribution side, the transmission side, and at the load side. So according to the utility, that is nothing but supply. The poor quality is defined as poor quality is a reliability. According to the load aspect we are considering, so poor quality is defined as power supplied for satisfactory performance of all loads which are connected to the power system. According to the end user side or customer side, any power problem manifested in voltages, current or frequency deviations that result in failure or misoperations of power quality equipment. So in modern power systems, the most serious and usual power quality issues are voltage sags. So that in order to improve that power quality issues, so power quality improvement devices are installed, and the cost of these devices are vary from rupees 4000 amperes to 70,000 amperes. The percentage sharing of different power quality issues are shown in figure 1. So according to this figure, the percentage sharing of voltage sag is nearly 60%. The percentage sharing of voltage fail is 29%. The percentage sharing of voltage transients is 8%, and voltage interruptions is nearly 3%. So by observing this, the major and most serious power quality issues are voltage sags. So in order to improve this power quality, custom power devices are installed, and some of the most custom power devices which are used to compensate this voltage sags are dynamic voltage restorer, DStatCom, UPQC, SVC, and etc. So why we are concerned about this power quality? Means in smart era, microprocessor controlled devices are digital, electronic and non-linear devices are extensively used in all sectors of industry. Nearly all these devices are sensitive. Electrical supply disturbances of any minute and cannot be operated properly. So hence, the use of sensitive loads such as diagnostic equipment in health centers, electronic educational institutions, detection centers, etc. over several years has been fourfold, which leads to concern the quality of power of sensitive loads. If power quality is insufficient, serious economic losses, so that means losses in manufacturing units and sensitive and critical loads, and lack of information could have consequences. Serious consequences. So coming to the classification, so poor quality issues are broadly classified as transients, long voltage duration voltage variations, short duration voltage variations, voltage imbalance, waveform distortion, voltage fluctuations, poor quality variations. So coming to transients. So if any, it is an event that is undesirable and momentary in nature. It is a sudden change in one steady state operating condition to another steady state operating condition. These transients can be classified into two categories. One is impulsive transient, another one is oscillatory transient. Impulsive transients. So it is subcategory of transient. An impulsive transient is a sudden non-power frequency change in the steady state condition of voltage, current, or both. So that is unidirectional in polarity. So that means either in positive direction or negative direction. So impulsive transients are normally characterized by their rise and decay times. These impulsive transients can excite the natural frequency of power system circuits and produce oscillatory transients. And the source of these impulsive transients are lightning. And the waveform of this and the characteristics waveform of this light impulsive transients are shown in figure. Coming to oscillatory transient. Oscillatory transients is a sudden non-power frequency change in steady state conditions of voltage, current, or both that indicates both positive and negative polarity values. It can be classified into three types: high frequency transients, medium frequency transients, low frequency transients. High frequency transient means these have frequency components greater than 500 kHz and typically duration measured in microseconds. Whereas in medium frequency transients, they have frequency components in between 5 to 500 kHz with a duration measured in tens of microseconds. So coming to low frequency transients, they have frequency components less than 5 kHz and duration from 0.3 to 50 milliseconds. And the characteristics of these oscillator transients are shown in figure. And the sources of these oscillator transients are back-to-back capacitor switching, transformer energization.